All right, welcome to Cassandra Lunch 19. We've been doing this for a while. This is obviously a response to the world being remote and being socially distant. We are actually, we do this meetup, Cassandra DC and Cassandra Chicago. We used to do it in the actual locales, but these days we're doing it all virtually. So let's see, somebody keeps pinging me. I'm going to close this window. Today's topic is a question that somebody had a while ago, which is, when do you use relational databases and Cassandra at the same time? And that's a really good question because most mature data platforms have different types of, databases, and there's a reason for having both of those. We have two co-organizers. Akwi and I have been co-organizers for a long time. Somebody wants to volunteer, happy to give up responsibilities. Basically, we're this is a volunteer effort, even though we're coming from the same company. The goal is that as a volunteer, you're able to get other people involved, speakers, sponsors. These days, the cost of running this meetup is fairly low. So, because, we used to buy pizza and beer and all that. We're part of a much bigger community, Data Community DC, very inclusive. We welcome underrepresented minorities and communities in asking people to come and present. Very diverse group of people in the DC community. So if you know anybody would like to speak, let us know. As I said, we're part of a bigger group. The Data Community DC is a collection of meetup groups around the DC area, generally around data. Night Owls DC is just a group of people that used to co-work at night and work on their side hustle. What we cover here is basically things related to Cassandra. And what I mean by that, Cassandra is no longer just Cassandra. Cassandra is DataStax, it's ScalaDB, it's Azure Cosmos, it's Amazon Keyspaces, because they're all CQL compliant, CQL meaning Cassandra Query Language, and how Cassandra works with other systems. All right, so Tu already kind of gave an intro, but generally this time, if anybody's new, you would say who you are. Group rules: if you have a question, you can go ahead and ask it in the talk. Just be polite. If you want, you can ask it in the Zoom question area, in the participant area under chat. You can use this as an opportunity to share. You don't have to ask a question. You can just make a comment as well. Right? It's a discussion. DataStax is a sponsor, so is GW. We have some local sponsors. We have organizational sponsors. Data Community is a nonprofit, so any donations are tax deductible at the individual or organizational level. I feel like I'm sounding like NPR pledge drive. Any announcements for the group in terms of upcoming events, hackathons, conferences, classes, etc.? All right. Well, we do have some. The DataStax, the company offers a lot of weekly workshops on their website. This is a weekly occurrence, Cassandra Lunch. Tomorrow, tonight, Cassandra and Sparking Cassandra for Machine Learning Model Deployment. This is, I believe, OB is third or fourth installment about Sparking Cassandra for Machine Learning. OB, what is it, the fifth? I don't remember. You've done so many.
It is currently either the fifth or sixth part.
Wow, great. And then there's open source BI in Cassandra from ARPAN tomorrow night. And TK did a presentation on Ansible all the videos for all of the stuff that we do at Anant, including the Cassandra Lunch, is recorded and put onto YouTube. And there are a bunch of other events also happening. So next week, getting started with Terraform and Kubernetes on AWS Part 2, intro to Enterprise Graph, DC Enterprise Graph, which is basically a graph database that stores data on top of Cassandra, and it's indexed by Solar. Cassandra as a service in the cloud. It's a comparison of the 3 different Cassandra as a service platforms out there. So lots of goodies coming up. All right. So just so you get an understanding of how we work, you know, we've been hacking away at a backlog of questions and topics that people have had. So actually, this is no longer needed. Before I go into the discussion of combined use of relational Cassandra, what are some questions that people have that we could put back into the backlog? And it could even be some of these because we didn't record these. So David, I know you've been learning Cassandra over the last few months. What's something that you are curious about that you'd like to do a deep dive on?
I have a question. I don't remember exactly lunch number 3. Did we cover data modeling in lunch number 3?
I don't think so. Okay, so we can do the data modeling.
Yeah, because that's something I want to get more or better at. So that would be something I'm interested in.
Sure. Good. It's a great one. That will take like 4 weeks. Yeah. So David, yeah, go ahead.
So yeah.
Sorry, you're muted. I don't know if you were trying to say something. David? Yeah, go ahead.
Yeah, can you guys hear me now?
Yeah. Yeah, we can hear you. Well, looks like you got kicked out. All right. How about you, Ryan?
Yeah, I had a couple that I was thinking about. One was I just recently read about the storage attached index, and that was that DSE is putting out, or DataStax is putting out, and just thinking like, yeah, it'd be interesting to learn more about that, especially, yeah, actually related to the data modeling, even, and how that would affect data modeling.
Right.
Yeah, and I guess kind of related to that as well is how does using either DSC search with Solar or with Alessandra, how does that affect data modeling as well? Just when you have these different things, different ways of searching, does that change like what you do in contrast to if you went through DataStax Academy and they're just talking about, well, they're just, it seems like they're assuming when they're talking about data modeling with just plain Cassandra, but how does it change when you have these different searching capabilities?
Yep. Give me 1 second. Right. Great. That's a good question, Ryan. And I'll kind of bunch this up as well, it's really a bunch of topics related to data modeling together. Okay, great. 2, what focused area of Cassandra are you trying to learn, or are you just trying to kind of generally trying to understand Cassandra for data science?
Yes, that's correct. I'm just trying to learn the general information about it. I'm currently learning Python and Splunk and SAS. So I'm just trying to, have an overview of Cassandra.
Gotcha. So Cassandra is a very general purpose tool. So in the realm of what you just mentioned, like SAS and Splunk, generally the work how it intersects with Cassandra is through a technology called Spark. Are you familiar with that? Like Apache Spark? So I'll go ahead and put this in here because even though Obi has a good series on machine learning with Cassandra and Spark, I think we can talk about different ways people do data analysis and data science with Cassandra. There's actually a really good data science, data analyst track that somebody's published, which talks about scaling machine learning and scaling data science. And after the basics of like Python and R and Jupyter Notebook, it's like, okay, so now you know how to make a little robot. How do you make it scale? And so then it gets into taking technology or picking models and scaling it. And so Cassandra and Spark are then used to take a model and then scale it for a big operation. So that'll be a fun discussion actually.
Okay, sounds good to me. Thanks.
Let's see, Obi and JB and TK, stuff that you guys want to do a deep dive on and learn more.
With respect
Go ahead,
to
JB.
Cassandra, most of the times, since it has to deal with a lot of data, it generates a lot of logs. Want to analyze those logs, and if it is possible, we'll be able to figure it out from the logs. Where is the catch?
Got it. Okay. Yeah, I think for the log analysis, you're talking about log analysis of Cassandra or log analysis in general of other systems?
Log analysis with respect to Cassandra and Spark.
Got it. Okay, got it. Cool. TK?
Nothing new. I too was also interested in like data modeling, like what Arpan mentioned.
And then lastly, Obi?
Any like subtopics on Cassandra administration?
Got it. Cool.
I had one more if I could just jump in real quick. Another one that came to mind was advantages of doing graph kind of stuff on Cassandra as opposed to, just doing single node graph, like what, basically what DataStax does, but, or with Janus graph as well. But how do you, what's the nature of using graph kind of stuff with Cassandra?
Yeah, that's a deep discussion as well. Cool, very good ideas. Now, this should take us until almost close to the end of the year. Great. Good. Well, today, as I mentioned, we're going to talk about relational and Cassandra. And I want to verify that you guys can still see my screen and you're seeing a workflowy outline. Okay.
Yeah, we can see it.
Yep.
So I actually have a deck that I had presented on before that I can walk through. I'm not gonna. The whole talk is actually much longer, but I'll walk through it because it'll give you an idea of why people move from relational to Cassandra, and in that we'll get some nuggets so that when we come down to the combined use, why do we still want to? I shouldn't say retain a SQL, but what are strengths of SQL and what are the strengths of Cassandra and what makes the best of both worlds work? So I believe the full talk is also on our YouTube channel, so you can check that out. Can you all see the screen with the presentation?
Yes.
All right. So I'm just gonna get right into the actual material. Let's talk about the differences between relational and Cassandra first. And if you've heard the spiel on how they were different before, that's great. I think every single time I explain it, I end up getting a question that's different. So actually makes me happy to share this again. The typical use case for relational database systems is, we make this kind of, essentially it's a graph, but it's a relationship between objects, master detail, right? One to many. So something has these things. Document attributes, which are one-to-one, meaning this document is this or has this property, this singular property. Lookup. By the way, document attributes can also be considered like hierarchical attributes. A lookup, meaning many different things are categorized as a type or something like that. So this is a contact, or this is a address, and that's just the object type. Or in the address, it would be address type. Is this a billing, or is this a shipping address, things like that. Connection end-to-end, which is, this thing is related to this with this particular relationship. So that's how we have been working in the relational world. When we get to Cassandra, essentially the reason why people go to Cassandra is that this model fails at high speed. The whole big data movement came from Google hitting a problem, which is they could not index the whole internet on one computer. And so they had to use many computers. They couldn't store the whole internet, right? They store the copy of the web page. And so the storage was a problem. And that is like the beginning of the big data movement. So when we're talking about relational, why don't we just continue using relational? What the problem is that to scale relational, you just need bigger and bigger computers, or you need to copy data to each of the machines as a master slave. There are new technologies such as called distributed SQL. Different databases are claiming to do that. But the question is still then, why would we use Cassandra when you have distributed SQL? Well, it's about speed. Cassandra is the fastest database that can scale to a global scale and have data replicated everywhere without any masters and slaves. Okay, so some of the strengths about Cassandra is that when you're moving from a relational experience, it's familiar, right? If the CQL table, it looks like an SQL table. CQL looks like SQL. You can't do arbitrary queries, joins, or transactions, so we have to change our data model. We're going to talk about that. But at the end of the day, it feels like an easy transition from SQL to Cassandra. While relational has this ACID ability, atomicity, consistency, isolation, durability, which allows us to always be sure that data is written or data is consistent. In Cassandra, we have something called basically available soft state, eventually consistent, which is that it will scale and eventually it'll be consistent, but you may not be 100% sure that the data is there. And actually, it has tunable consistency. You can tune it to say, when I write this data, it's okay if only one of the replicas has information. If I write this data, I want all the replicas to have information. And if you're new to Cassandra, what replicas means is that because we're scaling data across the globe, in order to make it available to many, many, many more users, we have to have replicas. And Cassandra makes that easy. It's just that once Cassandra replicates the data, if you update the data or if you retrieve the data, you can choose the consistency. Some of the main limitations of Cassandra are that we can't do joins, views, and arbitrary queries. In relational, you just put stuff and you relate them, and then you can do any type of query. In Cassandra, we create the view that we want to populate, and then we read from that view. If you use Spark, if you use the indexes that we talked about earlier, then you can do some arbitrary queries, but you can't do joins. You'll need Spark to do joins, even if the search indices or even if the storage attached index helps you query the information. Some of the main benefits of Cassandra is that it's got a very malleable schema. And what you would consider a row in relational can be part of a partition in Cassandra. Meaning, if you have a set of data that you want to get very quickly, you can design the data model so that it's a tabular set of information in a partition, and that allows you to store, let's say, master detail would be stored in one partition. Master list and multi-data center. Master list means that if you have 6 nodes in a Cassandra cluster with one data center, none of them is a master. They're all equivalent, and we can keep adding new computers to grow that, and it'll all scale without having a central master node. And then if we decide to replicate that data center into another part of the world, let's say East Coast and let's say London, those 2 data centers will be consistently replicating data without any masters. So there is a picture of why a global retailer would use, let's say Apple is a big user of Cassandra. They're a retailer, but they're really a platform company. If you are in Europe, if you access your data, it saves the data in Europe, but then if you go to the US, you'd be accessing the data via the US API, but the data would be consistent. They don't need to necessarily run a replication or synchronization job. Cassandra is doing that synchronization for you. That ability to power a global cloud API is the main reason why people end up using Cassandra. Well, actually, you know what? I should have walked through this. So yeah, you can have multiple data centers, and any given computer can act as a point of entry. You don't have to necessarily talk to one computer or another. You can have these global data centers. The way the data is stored in Cassandra is under the hood. It's a key value. So each column has a value, and if you don't give it a column and a value, it doesn't store it. So your table could have 1,000 columns defined in the schema, but you may end up only using 2 of the columns. That's fine. It will only store what you give it. One of the things that people don't know about Cassandra is that you shouldn't have more than about 150 or so tables in one, or even 200 in one cluster, because Cassandra is basically running a set of microservices to manage the data for you. So if you have a table and you're not using it, you should just get rid of it. But because it's doing this work to manage this data globally, essentially for you, and make it available globally for you, there's a cost associated with it. And so to mitigate that cost, what people often do is they separate clusters from different domains. What you see as a table in a query is, hold on one second. So basically, what you see as a 2-dimensional representation as a table is stored kind of like this. It's hierarchically stored. It's actually all stored as strings in something called a sorted string table, and it's compressed nowadays. I'm not getting into the reads and writes, but I'm going to fast forward to essentially when people move to Cassandra, what type of architectural changes they have to end up making. And many times the transition from relational to when we go from relational to Cassandra, there's often a shift from monolithic applications to microservices. Now, that lift and shift from relational to Cassandra rarely always works magically. So one of the big reasons why people would use relational and Cassandra is that they're in the middle of transitioning their services from relational to Cassandra. And the best way to manage that is to adopt a microservices approach. Before we even get into kind of the denormalization, to adopt a microservices approach where some parts of your application end up using a relational database and other parts are using, let's say, Cassandra. And then over time, these services can be replaced, they can be backed by a different database. Okay? Still, even after you move everything over to Cassandra, there's still a really good reason to have relational databases. And, you know, the way that you can manage a multi-data system is if you adopt CQRS, which is command query request segregation, in which everything that happens in the system is coming from an update in as a series of events, then your event processor can update Cassandra, and it can also, let's say, update a relational database. Why would you want that? Well, if you have a database like Cassandra, it can power an API for millions, if not billions of users to read information. But what if you want to do analytics on data and have very, very fast queries, and you're not happy with using Spark and Cassandra to do that, and you want to do visualizations? Well, what you can do is to simultaneously update the relational database that will only be accessible by maybe the business analyst and the BI team, and at the same time, you're updating the Cassandra database. So that's a common use case, that you mirror the data. The operational system is actually Cassandra, but you keep your relational data up to date so that you can do the queries that you want that you couldn't do in Cassandra. And this is not replacing a kind of transactional system. We're talking, this is purely an analytics use case. Another reason would be that if you're doing, and this is an excuse rather than, I think, a real reason, if you're doing e-commerce and you need to make sure that your inventory is extremely accurate, you know, like for example, if somebody goes to buy something and it's not technically available because it's been sold to somebody else, if that data is inconsistent, then the person will end up buying something that doesn't exist. Well, if you use tunable consistency, you can avoid that problem. But some people will use relational databases to power the transaction, and a transaction in a relational database it's either able to do it or it's not able to do it because there's a lock, or it's able to be also rolled back, right? If something doesn't happen all the way, it can be rolled back. And something like that doesn't exist in Cassandra. So we talked about, one use case of relational and Cassandra is that it is used side by side to power microservices until everything is transitioned over. Another use case is if we use CQRS, we use it to mirror data and make sure that that data is available. Okay. Another use case is, and I may have to find a picture online. Actually, this is actually in our intro deck. Is sometimes data is going to get processed into Cassandra because it needs to get. This is exactly what I just provided you earlier as an example. It's nothing different. Instead of using a Postgres database, they're using Redshift, which is a data warehouse, to do an analysis, whereas they're using Cassandra for real-time access. What I really wanted to show was something slightly different. Let's see if I can find a better picture. No, this isn't it either. So just imagine, this kind of gets at it, but just imagine, we'll go back because I don't want to confuse you guys. Imagine that we have everything happening on Cassandra. but doing a pure mirror of the copy in the data warehouse or the the report database, it's not efficient. What we end up doing is we ask ourselves, what can we do with Cassandra and Spark that relational can't do? So in relational databases, no matter, unless you're using Oracle, which has some machine learning built into it, generally you're not going to be able to deploy a model and get some predictions on something inside SQL, right? So what we could do is we could take the data in Cassandra, run Spark job on it, get some predictions, and then put that in a relational database so that we can do queries, arbitrary queries and visualizations in Tableau and BI tools like Tableau, against a SQL database that is essentially a byproduct of Cassandra plus Spark, right? So it's a data product. It's not something that you would write data back to, but it's something that gets generated every so often. And that is really another way of doing CQRS. It's just that the generation of the report table is happening in a much more delayed fashion than in real time. I believe we have an article that kind of talks about data platform. Okay, here we go. So generally in a data platform that is, mature data platform, you have a bunch of data coming in via events, API calls, stream, batch processes, and internally your holistic data platform would have a data warehouse, a relational database, a Cassandra database, or something like Cassandra. You have queues, and then either in real time, events are sent back out, databases are updated, or report tables are created, or it's done on a batch process. So, ideally, if you're using relational databases in a business platform, you're using it because you like using things like Tableau, MicroStrategy, Power BI, just directly connecting to the database, doing, creating dashboards and so on. And that data, once it goes to Cassandra, is not as easily queryable. You have to have a lot more resources to do the same type of query. You have to potentially, duplicate the data in another data center, run Spark on it, and then it all comes down to cost. It's actually much cheaper to churn the data in an analytics process, publish it to Postgres, publish it to SQL, and access it like anybody would. So if you're a data analyst, you may be working on a platform that has Cassandra at the heart of it, but you're using report tables that are either updated in real time because of the software architecture, or it's report tables that are generated because of a batch process that updates it on a nightly basis or a few times a day. So coming back to relational versus Cassandra versus combined, here we're getting consistency, we're getting speed of queries, arbitrary queries, right? You can do joins, views, etc., and we're able to use existing BI tools. In Cassandra, we're getting speed of predefined queries, We can't do joins, we can't do views. Well, technically we can materialize our views. You can replicate the data across the world, get read and write from anywhere. Okay. So in a combined system, you use Cassandra for transactions. You can use it for analytics. right? When I mean by big data analytics, like you're running Spark on it, right? Spark, Flink, you can run Hadoop, MapReduce on it if you want, but why would you do that, right? You would just use Spark on it. There's no reason to do that, so I actually shoot that out. But then you would use relational potentially for critical transactions, right? So whereas here we do certain type of transactions, you can have, let's say, transaction history. So if you buy something from an app at like Starbucks, it may be powered by Oracle, but then your receipt history is stored in Cassandra. Let's see, another thing you could do here is analytics, but I'm not going to call it tiny data, but just, you know, regular sized analytics. Remember that data warehousing technology is expensive. Cassandra is relatively cheap. You can have petabytes of data in Cassandra. You can have petabytes of data in a data warehouse. One of them is going to be more expensive. So, you know, generally what we're doing is there are data warehouse, which is you know, SQL compliant, but it's not exactly relational. So people will use something called like Redshift, or we use Snowflake, right? Or they will create a data mart on Postgres or MySQL or SQL Server. Okay. And it's best if it's tied together via some sort of message queue, right? The message-oriented architecture, using microservices on top of it, and then sometimes batch processes. I might be able to show a picture that, there we go. Maybe this has it.
Just real quick, by batch processes, what were you referring to exactly?
Yeah, if you want to create a data mart, you would churn the data inside Cassandra and then publish a set of tables in Postgres, and then people would access that.
Okay, rather than real time, just update it every so often.
Yeah, exactly.
Okay.
Because you know, people say they want real-time analytics, but they don't understand what that means. Real-time analytics means that, let's say you're a customer and you go into a Dunkin' Donuts, because you have a profile that exists in Cassandra, and you cross a geofence, some machine learning process figures out what you like, right? And it recommends it to you. Well, quite honestly, it doesn't have to find out that what you like every minute or every second. It can look at your buying history for the last 5 years and know what your current favorite is well before you walk into it, and that could be a batch process. That's on the Cassandra side to push that data. But at the same time, you know, a business like a marketer or like an operations person, they're not watching a screen running queries every 5 minutes. They're making business decisions maybe on a daily or weekly basis. So when they get the data and they need to do some queries or they need to do some, you know, charts and dashboards, they just need a data that's maybe 4 hours old. Right? That make sense?
Yeah. Thanks.
Cool. Here we go. I'm looking for a diagram that would really represent kind of what we're talking about here, and this kind of gets at it. So, you know, there's business views that people use, and then, you know, the batch part would publish to not only Cassandra, but it could publish to like a Postgres database. This one is again, here's one, right? So relational databases is being used, Cassandra is being used, Hadoop is being used. It sends a bunch of events to Kafka, which is then churning it, and then it publishes it back in Cassandra for people to use. So what this means is that intelligence inside relational database can be scaled by pushing that intelligent data to Cassandra. Let's see, there's a couple other ones. Yeah. There are examples, but I can't show them because they're customer sensitive architectures. But it's a common scenario. It's called Lambda Architecture. I'm not talking about Amazon Lambda, but basically you have a streaming or a speed layer, and then you have a batch layer. Eventually, both of them are reconciled every night or every whatever, so often via the batch process. And that's the reconciliation part of it. It's not necessarily that this is doing something different. Some of the architectures I've seen is that they're using streaming for one type of operation and they're using batch for another type of operation. And that type of operation is to publish those data marks. Okay. Cool. While we're doing this presentation, I got a couple of other questions that we could talk about in the future. Optimizing queries, data modeling, workarounds, or joins. Backup, I would put that under administration. We did talk about it, but we can talk about it more. There's a video on Lunch 15 is about backup and restoration. Tools that can be used with Kubernetes deployment of identifying. Okay, that's a really good one. So I'll put this as Cassandra on Kubernetes 2.0, deployment and administration tools. Cool. Excellent. All right, so I talked as much as I could without showing anything that was sensitive. This is probably a good topic to then talk about again when I can create a better diagram that I can show you guys. But any questions from today's topic? Nope. All right. Well, thanks for coming. Appreciate you guys showing up. As a reminder, this is every week, same time, same place. We are also on YouTube. So, if you go to YouTube, Anant Corp, there's a playlist just for Cassandra Lunch right here. And all the videos are there. If you are interested in the blog post and the deck that is going to be accompanying today's recording, go ahead and sign up at our mailing list, blog.anant.us. And so, for example, Ryan's talk from last week is already up. And it has an explanation of what we talked about, as well as pictures and a link to the video.
Real quick, are those workflowy notes that you write out for these lunches available somewhere too?
They're not available, but they're used for the blog post. That's a good suggestion. I think I'll consider publishing them. Yeah, I'll consider publishing them. I think I can publish a read-only view of it. So yeah, it's a good idea.
Okay, cool, thanks.
All right, well, everybody, thanks for joining Cassandra Lunch 19. Looking forward to seeing you guys at Cassandra Lunch 20 next week. Have a wonderful rest of the week and see you all soon.
Thank you.
Thanks, man. You too.
Thanks.
All right, bye-bye.